Okay, let's go ahead and get started. So hello and welcome everyone. Thanks so much for joining us today. Today we'll be talking about drones in oil and gas. So the title of today's webinar, as you can see on the cover slide, we have Drones in Oil and Gas, How Chevron Uses Drones to Improve Safety, Reduce Downtimes, and Save Money. We really appreciate everyone taking the time to be with us today. We do want to take a moment to acknowledge what a difficult time it is for everyone throughout the world right now with the ongoing pandemic. Um, it's definitely a hard time. We appreciate you tuning in, whether you're in your home, probably your home office, wherever you're tuning in from. We really appreciate you being with us. So my name is Zach Dukowitz. I'm the content marketing manager here at Flyability. I'll be your moderator for today. And the stars of today's show are both folks that work at Chevron, have a lot of experience in inspections and working with drones. So Mauricio Calva is a non-destructive examination expert at Chevron. He'll be speaking today, and joining him is Larry Barnard, who works in downstream and chemicals with UAS, and he's helped build the drone program at Chevron. So we're really excited to get a chance to hear from them, draw from their firsthand experience working with drones in oil and gas. Just a few housekeeping items before we get started. The first one is, and this is actually really important for today, to please ask questions. Because we have hundreds of people tuned in, we can't make everyone's mics live. We can't have people chiming in with questions. It would just be chaos. But we really want to hear from you, and we want this session to be as engaging and interactive as possible. So please take advantage of the questions pane or the chat pane, really wherever you feel like chiming in. We want to hear from you. If there's something that you want to know from Mauricio or Larry, if you have a question about Flyability's drones, anything at all, please get in there, ask questions. We really want to hear from you as much as possible today. And so I mentioned a moment ago that questions are especially important today. You'll see in today's agenda, we've devoted a huge portion, half of the session, to a Q&A. So for the first 5 minutes, we'll be going through the intro. That's what we're doing right now. And then for 20 minutes, Mauricio and Larry will be presenting together on the use of drones in oil and gas at Chevron. And then for the last 30 minutes, we'll be doing a Q&A, which is really going to be sort of a roundtable discussion. So I've got a few questions that I'm eager to ask them, but I certainly don't want my questions to be the only ones that get asked. We really want you to join as well. So, and just to put this in context, we usually devote more like 15 to 20 minutes to the Q&A, but we got the impression from a lot of questions that we got in advance that people were really eager to get to engage directly with Mauricio and Larry and draw from their experience. That's why we've extended the Q&A to allow more time so that really we can just, hear about what they've done and what they know. So we're really excited for that. But again, please use the questions pane. Please feel free. And feel free to ask questions at any point. Don't think you need to wait till the end. We will be archiving your questions in a document that we have set aside. We have a lot of people working behind the scenes today helping us arrange these questions and make sure they all get answered. So whether your question gets answered in real time through the chat pane or gets asked during the Q&A, we're devoted to making sure that we address every question that gets asked. So let's dive right in. Today's speakers, I've already mentioned their names, but I'd like to introduce them a little more deeply. So Mauricio is a non-destructive examination expert, or NDT expert, at Chevron. In his work, he tests and implements new inspection technology, including drones, right, to help improve safety for employees, to improve general processes, to try to improve overall ROI. Mauricio gets out in the field to do testing. He is on the go quite a bit. So there's testing that happens in different environments. On a typical day, you might find Mauricio in a lab inspecting equipment, reviewing inspection procedures, or out climbing a ladder even to test new inspection techniques in real life scenarios. We'll also be hearing from Larry Barnard today. And Larry, I hope I'm not butchering your last name. You can tell me when you start presenting. I should have asked you. So Larry has spent over 30 years working in oil and gas in downstream refining process plant operations, maintenance, and reliability. So he brings just a wealth of experience to today's conversation, today's presentation. Larry's work has taken him all over the world to support Chevron's operations. He's been to places like Australia, Singapore, South Africa, Wales, working with Chevron. He's a specialist in workflows and technical standards. He has deep experience with building and implementing new programs, and he's brought that experience to bear in his work helping to develop the drone program at Chevron. So we're really excited to hear from both of these guys. I'm going to hand it over to them. They have a presentation that they're going to do, and then we'll do the Q&A. So give me just one moment, and I'm going to make Mauricio presenter right now. There we go. Okay, you guys are live.
Okay, well, thank you very much. Thanks everybody for being here. Yeah, we acknowledge what is the situation around the world, you know, especially those companies related to oil and gas. You know, we are in a very, very special situation. So I'll let Larry introduce himself, and then I'll let you know a little bit more detail what is my job in the company. Go ahead, Larry.
Hey, good morning, everyone. Larry Barnard, El Segundo Refinery, representing a lot of business units within Chevron, downstream and chemical and otherwise. Had the distinct pleasure of working with or leading a lot of teams and a lot of different work groups over the years. Very exciting times with regard to robotics, especially aerial flying robotics. We were the very first Chevron facility within the portfolios to stand up an internal UAS program where we've purchased vehicles and have employees operating those vehicles for the greater good. We have a variety of vehicles, 6 aerial, 2 of those internal, and submersibles as well. So we do offshore and onshore, subsea or subsurface. Very exciting times, and people are definitely seeing the business value with regard to risk reduction, efficiency gains, and more and better data by use of these vehicles. So it's very, very exciting times. I'm happy to be a part of it.
Thank you, Larry. And well, my job within Chevron is to look for better ways to do inspection. I work for a organization within Chevron that is called ETC, Energy Technology Company, which is the central engineering, technical support, and research and development group. We support the whole organization, you know, from exploration, production, transport, process, manufacturing, and terminals. So we cover the whole integrated business. So let me start this presentation. So why are we using robotics in Chevron? Well, the objectives are, of course, to reduce risk and reduce cost. We're also looking for alternatives that will help us to increase the quality of the data and the efficiency of the whole inspection process. You know, this is my job, right? This is Larry's job, and this is many others in this organization job to look for, in general, better ways to do this work. So, what is really driving these needs? You know, looking for maintaining these facilities so that they can operate continuously and without interruption, avoiding any products or substances coming out of the pipes, you know, and affecting the environment, the workers, or our neighbors is of the highest importance. Of course, being able to demonstrate that we comply with all the requirements that regulatory you know, rules are imposed on us. So this is why we're doing robotics. of course, robotics fits very well, right? We started exploring robotics mm, quite some time ago. I'm gonna say almost 10 years ago. We saw this opportunity. Back in 2015, I met Viability when they were just starting. They won a prize on a conference in Vienna, and I approached them and I said, "Listen, I'm sure we can use your tools for some of the work we need to do." And from there, we start talking, and they start talking to other groups and other companies, and we've been very, very close to Viability throughout all these years. The same has happened with several other companies that we've been working very close to develop these systems. In this presentation, we're not gonna talk about the capabilities of the system. We are convinced. I mean, we don't need to tell you about the quality of the results we can get. I'm not gonna tell you about the efficiency of the work we can get with these machines. I'm not going to tell you on how much time and how many resources and how much money we can save with it. We are convinced, right? We know this will work. Both Larry and I were huge advocates of these technologies. What I want to do today is to tell you what do we need to do? Where are we in this technology? How are we making progress or not? On some of these applications, and share with you the hardest part. Saying that everything is great and that we're going to be using this tool in every place for every inspection, we're not there yet. So go ahead, Larry. I don't know if you have anything else you would like to add at this point.
I appreciate how you frame that up. We are definitely convinced that this technology can help. We can share that it has helped. We've used it with a variety of scenarios. I guess we might get to this in the Q&A session, but I'm hard pressed to find another technology or product that's made such a massive jump in advancement between version 1 and the next version. Between the Elios 1 and the Elios 2, it's like an order of magnitude improvement with regard to its capability, with regard to the Elios 2 ability to enable people to operate this technology that aren't historical, legacy, typical flyers or robotics fans. Very easy to operate, very capable payload. The addition of lights, I mean, it's just phenomenal. The optical flow sensors and its ability to maintain stability is a huge jump. So like Mauricio said, we're convinced, and it does a very good job of getting us in and out of equipment quickly at a very cheap cost with very good data.
Okay, so these are the questions that we need to answer internally to progress this technology. There is for us a difference between doing a test and doing a pilot and making a demonstration and talking to people and having a meeting where we can show them that, out of the 64 vessels that we inspected last year with robotics, in most of them we can demonstrate, we say 50% of the time, and we reduce the resources to a level where these solutions are very attractive. The integration, making these solutions a normal way of doing business is where everything ends, right? For me to be in a refinery and flying around this machine and showing them how great everything is just the beginning. We are not done until these solutions become a normal way of running inspection in our facilities. So these are some of the questions that we need to consider when we try to jump that very, very steep process of getting a refinery from stopping what they are doing or getting an offshore platform from rewriting their procedures and rewriting the way they do this work and adopting these new technologies. That is when everything ends, and that's where we are. We're in that process, right? So, what information is important for the end user internally, right? The engineers that will use this information to make decisions. What are they going to do with this, right? What about the pictures? What about the videos? What numbers do they need to make calculations? Who's going to do the analysis? In what format? In what conditions? How the report needs to be written so it makes sense? Where are we going to put all this? I mean, if I put it in my hard drive or Larry's hard drive, it makes absolutely no sense because it's only him and I that knows where things are. I mean, I can store 1,000 pictures from inside a vessel, and if I don't know where those pictures are exactly from, they have absolutely no value, right? And then once we have this information stored, what is going to happen? Who's going to have access? How often we need to have access to that information, and so on and so forth. So, Larry, go ahead. I know that you have been exploring some of this data management and the struggle. So, what is your take on all this?
Yeah, thank you. I agree 100%. We've had many chats about this. Once you get over the allure and the amazement of the tech, you start to get to a point where you realize you're going to be drinking data from the fire hose, and it becomes less about the vehicle and its capability and more about what do we do with the data. So, and we're very much in that place now. I think a lot of what Mauricio framed up as, what do we do and where do we go from here has to do with a term that's sometimes overused. It's about scaling. It's about enabling people to use this as just another tool. It's not a potentially specialized thing where you have specialized people. However, you could, choose to go that route. Arguably, you could get more capability for your organization if you enabled more people to use this tech as a tool and have the infrastructure sitting in the background, have the questions answered with regard to how your new data is going to interface with your legacy systems. So your maintenance management system, your mechanical integrity or inspection systems, like Mauricio pointed out, the ability to notate, save, associate, review, and maybe most importantly, because of file size, document retention strategy. When do we say we've kept this long enough and chuck it out? So those are all things to consider here and all things that we've considered. We don't have everything figured out, but we are certainly on the road. We're on the way.
Yep. Okay, so what are the applications? Where we've been using and where would we believe will have the most impact with these technologies? So as you can imagine, all our systems are in operations for very long periods of time. So any type of inspection we can do with the systems in service, which in some places is called non-intrusive inspections or in-service inspections, are very important because any information we can gather now, we can save it from the times we need to take these systems out of operations to do modifications or maintenance or repairs. So these are the two times that we have. The in-service inspection is the longest time, right? We do not shut down these systems for many, many years. And then we try to cramp all the maintenance, repairs, and additional inspection just in a few weeks. So the in-service inspection is very important. And this in-service inspections is normally what we call routine inspections. This is planned. We try to do to put together a structure of what do we need to look for, what type of damage mechanisms, where are likely located, what type of information is representative of what is happening on a circuit. Just to give you an idea of the size of the work we have, in a refinery like El Segundo, we did an evaluation and we counted around 50,000 miles of pipe that we have in just a single facility. There is just no way we can do inspection on every inch of every pipe on that refinery. So we need to be very selective, and there are a lot of criteria. That goes back into a plan for execution where we collect this data, right? Then the other part is during the shutdowns or the turnarounds, only those areas where we have no access during in-service, or areas that we need to make verifications, or damage mechanisms that cannot be detected or observed with the equipment in service. Those are the only ones we do during turnaround and shutdowns. In most cases, these inspections happen inside the equipment, and the requirement for ingress in confined space is a huge part of this process. So anything we can do to remove the personnel from the confined spaces and do work remotely with robotic systems or other devices is very welcome. As I mentioned before, we are working in both areas with robotics and with the Helios systems, both of inspections during in-service work and inspections during shutdown. All right. Anything else, Larry, that I forgot?
Yeah, not that you forgot, but maybe a couple additional perspectives. We're seeing a lot of interest from process engineering folks. I've been made to understand that a typical, if there is such a thing, a typical fixed equipment inspection for integrity or regulatory or compliance is one type of inspection. But there's a whole group of folks who are very interested in other types of inspection where they focus more on the operability, internal probes, thermal wells, instrumentation, operability of internal components like dampers, etc. So it's a different flavor of inspection with a different approach. It's not a typical fixed equipment inspection for integrity purposes, etc., but more operability. So we have started to, and there has been interest from, we've started training the process engineering folks to utilize this tool. This is not historic, it's not typical. I can tell you that the engineers that have gone through the training program are very, very excited about utilizing the tools. We've scheduled quite a few folks to be trained, and they will be using the tech, the Helios 2, on upcoming turnarounds to inspect some equipment and some of the operability components within those pieces of equipment. So this is something we didn't foresee, but it makes sense, because if we really believe this is an enabling technology, the only way we're going to enable is to enable more people to use it, and very exciting. With regard to cost and time, historically, shutdowns there's a lot of anxiety around turnarounds and shutdowns. Some of these process plants in a normal market could be worth up to $1 million a day for every day that they're down. Money we're losing. And as tight as we can contract a turnaround schedule and as small as we can make a turnaround work list, obviously that's going to benefit us. So doing as much work as we can when the unit is on the run, and limiting that turnaround or that downtime to just those components that cannot be inspected or repaired any other way, the Helios gives us a massive advantage with regard to getting in and getting out and not getting in the way of anything else that might be planned for that vessel, whether it's coatings, CO2 or hydroblasting, replacement, sheathing, whatever the case may be. So the Helios allows us, if a vessel is scheduled for something like a catalyst change, you start to really challenge the inspection groups, typically with regard to how much time they need to look at stuff when nothing has been identified as needing a repair. The LES allows us to get in there and get that inspection done very, very quickly and not get in the way of the planned work. That's a huge benefit, and it saved us tons of money.
Mm-hmm. So this process we follow is listed here. You may be familiar with it. In order to get a successful application of robotics, we need to be very careful on the planning and preparation, and then in the execution, data collection and analysis. I'm gonna rush a little bit. We're running out of time. We are just gonna mention two quick examples on some of the applications we've done recently, and the first one is an inspection on a stack that Larry did a few weeks ago. So Larry, if you want to explain a little bit of what you guys did on this inspection and what was the scope of the work.
You're referring to the SRU stack?
Correct.
Yeah. So we were asked by a fixed equipment inspector to inspect a stack in a sulfur unit. Should I pull up video on that? Or should we just chat about it?
I just chat about it. The video is actually shared at the Flyability site, so
Gotcha.
they can we can direct them to the.
We'll track down the link and we'll share it after the presentation. Sorry to hop in and interrupt.
Yeah, no trouble. Yeah, we were asked to fly an SRU stack in lieu of a historical type inspection where scaffolding is built. We utilize the LEOs to run in through a manway at the bottom and up to inspect refractory lining, general overall condition of the refractory all the way up, and two separate sets of temperature probes that are tied to safety instrumented systems. We did that very easily. We did it using, I believe we used a total of 2 batteries, so we're looking at about 16 to 20 minutes total flight time. One of the things I failed to mention is we took advantage of the training that LEOs or Flyability provides. Sorry. We have 2 folks within the refinery here that are qualified to train others on the Flyability systems, and we've taken advantage of that. But that really enabled us to get in here and do, it was our very first mission right after training. It went off without a hitch. The inspection group was very happy with the data they captured. They were able to identify things that needed additional attention or notes for the inspection records, and we carried on. In addition to that, using Pix4D software, we were able to make a video of the actual inspection from the imagery that we captured, which basically just provides the end user or the viewer with a fly-through of the asset itself.
All right.
That was very well received. I don't want to take too much time talking about it. Late.
Yeah, and on my side, something we did is using the Helios to do fly outdoors. You know, in these pictures, you can see an arrangement of piping on one sector of the refinery. You know, visual inspection is the primary tool that we use to discover areas where we may have some challenges. So getting somebody to walk and to climb and to get to every one of these locations to discover any potential damage is impossible, right? So we experimented with Helios just flying in the middle of this rack, you know, in very restricted environment. The pilot we had was very well trained on the operation of the Helios. He was able to compensate to a breezy kind of day. It was not calm, but he managed to give us incredible views of the condition of these piping systems. So that has become now part of the of these programs of inspections that we have in our facilities. Again, you know, we're not done. We're still trying to introduce all these as part of a normal way of doing business. And that's it. That's all we have for now. So please go ahead, and I guess we'll go to the session of questions and answers.
Okay, great. Thank you both so very much for the presentation. And we'll also be having Marc Gondillon, our head of marketing, chime in now too for the Q&A. So Marc's going to be asking some questions from the audience. We've also, as I mentioned in the intro, got some questions written up. So, Mark, do you want to start things off, or do you have a question that has been coming up a lot that you think these guys should answer?
Yeah, sure. I think that there's one question that comes up all the time when it comes to using robotics in the oil and gas industry, and I think you've thought about that, Larry and Mauricio. I think there, you know that the Ilios is not intrinsically safe, so basically it's not able to be used in explosive atmospheres. So this is no limitation, and today there's no technology available that is able to enter those atmospheres. And I'm wondering, how do you go, around that? How do you go past that limitation? I think this is really interesting for the audience.
Yeah. Well, the way we address this issue is preparing the equipment for human occupancy. We are not to the point where we can replace every single activity that we have inside these vessels using robotics or remote operated devices. After we shut down the equipment, we do a initial cleaning, trying to remove all the residues. And once the systems are off, we open them, we remove the vapors and the gases, and then we do an initial inspection, which actually is the one that Larry was referring to, where we evaluate what is the general condition of the vessel. In many cases, we need to have crews inside doing additional cleaning. In many cases, we need to erect a scaffold just to reach certain areas where we need to do repairs and so on and so forth. So we still need to prepare those vessels for human occupancy. And there is a whole procedure, right? So once the vessel is prepared for human occupancy, it's deemed to be secure for equipment that is not certified for explosive environments. So, of course, and you will know, it's in my list of things that we would like to have, but it will not make sense to have only one tool that is certified. It will make only sense when everything we use, for the cleaning, preparation, inspections, and repairs can be done with remotely with remote systems. So we're working on it, but that's the answer. Larry, I don't know if you have anything else.
Yeah, I mean, it's risk mitigation every time. I would argue everything we do and every day that we come to work, when you're walking around in a facility like an oil refinery, we're not making cotton candy. There's risk assessment that happens from the time you come in the turnstile. So the utilization of robots, whether they fly, crawl, or swim, is no different. And being aware of those risks and being able to soundly mitigate those risks is of the utmost importance. If we could not mitigate those risks, we would not be using this equipment. It's as simple as that.
Right. Yeah. I've heard also that sometimes people can utilize the environment using sorry, I forgot the name of the gas, but you can actually neutralize the environment, and humans cannot breathe, but robots can still fly. Is that something you've tried to mitigate risks?
No, I don't. No.
Sorry, it's nitrogen. Got it.
Nitrogen, yes. No, not for these applications. We use nitrogen for part of the maintenance. Certain type of conditions require the use of nitrogen, but we have not proposed the use of nitrogen for operation of these systems. Again, it hasn't been necessary. Listen, the other part that is important is for us to start using these technologies, we need to make a very smooth transition. The more conditions Larry and I impose to the use of these systems to solve problems, the harder it's going to be to make that transition. So our decision has been that the least we need to ask the operations and maintenance groups to modify the way they are running their business, the better chances we have to introduce technology. So instead of we asking them to change things, we are trying to adopt our solutions to the way they are doing business and then start going, from that point over. So that's a deliberate decision to reduce this asking for more and putting conditions and requesting changes, because it's a lot easier for them to say, no, we're not going to do it, because we just don't have procedures or ways to do this type of work.
Right. Thank you.
Thank you both. Yeah. So before we move on with questions, I was actually so excited to get into the Q&A that I didn't talk about just a few things that usually I want to cover before we start doing questions. So real quick, you'll see on your screen, there's a slide that says replay. So if you're wondering whether you can view this webinar again, the answer is yes. We'll be sending a recording of it to you via email, of course, afterwards. So just want to make sure everyone knows that. And then also we want to make sure everyone's aware that this webinar is part of an ongoing series that we're doing. On your screen, you'll see webinars we've already done. And of course, today's webinar on oil and gas, Tuesday, April 28th. We have 2 more coming up on indoor 3D modeling use cases. That's going to be this Thursday. And then Thursday, May 14th, we have another webinar on drones in power generation. And there will be more webinars coming even beyond these. Check out the link that's on the bottom of the slide in red to see other webinars that are upcoming, including webinars on the use of drones in chemicals and other industries. So sorry for that brief aside. Let's go back to the questions. I have a question to piggyback on the conversation we were just having with Mauricio and Larry. You were talking about trying to find ways to address current situations with the technology that's available. I'm wondering, what do you see as some challenges for adoption within Chevron or adoption in general in oil and gas of drones and robotics in general? If you guys could speak to challenges that you see right now in adoption and ways that you might be able to overcome those challenges.
Yeah, absolutely. Chevron is a different company now than what we were 2 months ago. And the challenges we have now are very, very special. We don't go through these type of scenarios very often. The economics, right? The economics of these solutions is taking a very high priority. The way I feel it is that for one side, we've been preparing for this, right? All these years we've been saying we have a better way to do things. We can reduce the resources we need to do inspections. We can do this faster. We can do more coverage in less time. And now, we are being demanded to use these technologies to solve all these problems. But things are not going to change unless we demonstrate that whatever solution we're proposing economically is sound, that we are not increasing the risk to the operators, and that the quality of the data and the quality of the images that we are obtaining with these tools is not less than what we've been doing until now. So not because I can go and say I can save 50% of the time of this inspection, they will drop whatever they're doing and start using these tools. Is being a lot more complicated than that. Larry, what is your take?
Yeah, I think when you talk about the difficulties, there's a wide range. General use, data storage, getting over the paradigm of legacy and historical ways of doing business and tools to do that business with. Those are some of the challenges. Getting people comfortable with the technology and how the data is captured. Getting comfortable with potentially new ways to analyze or assess that data to make business decisions. That's not trivial. You're fighting history. You're fighting the old way of doing things, where a person is up on scaffolding and they have a flashlight and they're poking and prodding and they're measuring, and Being able to do that slightly differently, with the benefit being time saved and risk reduced, personal exposure time reduced, working at heights reduced. These are all great things, but at the end of the day, somebody still needs to feel comfortable and get business value. We need to answer business questions with this. Otherwise, what are we doing, right? So those are some of the challenges with internal inspection. External inspection, the available platforms in North America, concerns about data security, not reliability. The other challenge is, do I stand up in-house? Do I hire contractors? Do I do a little bit of both? What we like to call a hybrid approach. These are all challenges with using the robotics. And then the complexity of the system itself. How much do I need somebody who's a real aficionado with this technology? They've been flying RC vehicles or driving RC cars their whole life. They took robotics classes at MIT. Or is this something we could give to somebody with a little bit of training and they can get a really phenomenal result really quickly? Those are the challenges, I think, with robotics.
Right. Maybe a question from the audience. I think you mentioned you use a process engineer, or you involve process engineer in the utilization of Elusu to perform inspections. But do you have other dedicated pilots in your team, or are you envisioning using only regular employees that are piloting part-time? And maybe is there any inspection that they cannot achieve where you would have dedicated resources for doing that?
So first of all, the use of this technology and the individual business units, whether they're upstream, midstream, downstream, offshore, aviation, IT, we have representatives and we have folks in their individual areas of operation who are either interested or are currently using this. We're lucky enough to have a global aviation safety assurance group with Chevron, and they do a fantastic job of enabling us through the use of a templatized flight safety manual. They provide audits and assessments and basically approve programs, but there's a lot of people either interested or starting to use it. We haven't got to the point now where we have regular flights at an individual facility that are frequent enough to justify a cadre of full-time pilots. I think that day is coming, but we're not there yet.
All right.
Larry,
Yeah, if I can add about the process engineering, that's Larry mentioned that we are discovering that the use of these tools had exceeded the applications on integrity and inspection. The process engineers on that step that I was describing, once we shut down equipment and we have access to it, the more information they can have as quickly as possible, the better decisions they can make. As an example, let's say we open a heater, a furnace, and we have some refractory in some of the walls. As soon as that equipment gets shut down, before we have access for people, if we can fly this system around and recognize that, something failed, something will need repair or replace, these process engineers will understand better how they can modify the process to reduce that damage, and how at that very moment they can take action, right, to order the equipment and materials to repair and modify or modify that equipment so that it will not suffer the same damage. So the process engineers still are there when they open the vessels after it's clean, but this is the first time they have high quality tools for them to get as much information as possible. That's a discovery we did in El Segundo. That was something that we were not really even considering until some of the process engineers told us, hey, come early in the morning and let's fly this thing as soon as they open the manway. I mean, I want to go see what is happening. And it opened a whole new group of applications that, on my side, as I'm more on the integrity part of the business, I would have never even considered. So it was definitely a great, now it's a very important part of the work we do.
Here's the aha moment for me. They were like, would you, the process engineers had asked, could you please, let's talk about utilizing the Helios-2 to fly the atmospheric column and this and the stack for the forced draft fan and some of these other components. And I turned around to them, I says, why don't you fly it? And they just looked at me and their head went sideways and said, yeah, you could fly it. We could teach you to operate it and you could answer your own questions. It's just a tool, right? And they had the aha moment. So that's exactly what we did. And that's what we're going to continue to do. We need to enable employees to answer their own questions. It's not like an ambulance or if you were a designs engineer, you wouldn't call the central tool room to bring you a scientific calculator.
Mm-hmm.
We don't see this being any different. Now, the complexities between flying externally with airspace requirements and operating these components or these robots inside of equipment where you don't have the airspace concerns and you have very high capability, very, very good stability, ease of use, there is no reason why we wouldn't want to enable more people to take advantage of this tech themselves versus making it a specialty item. I mean, if I go on a 4-day trip to Vegas, we don't fly drones that week? Doesn't make much sense.
Yeah.
I love that story, Larry. And that's, I mean, with the Helios-2, we really wanted to address ease of use. And, of course, not everyone's going to be able to pick up the remote and be able to fly it, the first 20 minutes, but it's certainly a lot easier to fly than a lot of other drones on the market. Your story really illustrates that. Larry, I had a question. You had this amazing image when you were presenting about the fire hose of data that gets turned on when you start using drones. And I think anyone that started incorporating drones into their workflow knows you suddenly have just a wealth and overabundance of visual data. So we're wondering, could you talk, you and Mauricio both, how do you manage data? And can you tell us about some of the tools you're using and just get into the details a little bit more about what you're doing with all that data?
Right now, we're getting closer, but we have set a path to complete a task to come up with an image-centric data management solution. It could be UAVs, it could be Helios-2, it could be submersible, it could be iPhone, it could be anything. It's image-based data. Primarily a method to upload and store. Along with that, there's some ancillary activities you want to do as far as classification, tagging, ordering, just telling the imagery what it is, where it lives, what it's associated with. And then further down the road, I think in the next phase, artificial intelligence methods, whether it's machine learning or some other method, all of that will be brought to bear on this data set. One of the examples I like to use is within a corporation, a vertically integrated oil and gas company like Chevron, which has a global presence and does a very good job of being a good neighbor and generates tons of data. Why do we need 72 pictures of the same tank? So having the ability in this data management solution of the future, tell it what it is, have one or two of them, let people have access to them if they need it. And I guess some of the other pieces are making sure that it integrates. You have export import to some of your legacy systems. So if a fixed equipment inspector had a report where he needed to attach or otherwise reference an image, whether it's infrared, thermographic, optical gas, RGB, it wouldn't be a big ask or a troublesome activity to take an image from someplace and attach it to the report or have some reference to it within the report. These are all things we're addressing. Right now, we're using a variety of methods, whether it's Microsoft products or terabyte drives, etc. And we're moving to, I think we're getting a lot closer on selecting someone and something to manage that, but it'll be a corporate wide. We'll have some standardization right out of the box, which is going to be huge, not only from Sarbanes-Oxley approach, but maintenance, rules, access, etc. It's a good way to go, we think.
Let me add one more thing on this idea of transitioning from how we're doing things right now and start using robotics and the Ilios and the other machines. One of the steps we're taking right now is that the inspector is together with the robot operator, and the inspection is driven by that inspector that is responsible for writing a report and signing a report saying that that piece of equipment is in condition to be put back in service, or that additional repairs or modifications are needed. So, in this transition work, as he sees something that he needs to put in his report, he will ask the operator to drive or to place that system in front of that anomaly or indication and take the pictures that he needs so he can explain in his report what is the condition of that piece of equipment. So by capturing those pictures, we are following a similar process that we have already established, right? So instead of him being in there hanging from a scaffold or a rope taking the pictures, now it's a machine taking the pictures, right? So that is been helping to make this a smooth transition from how we're doing things to how we are, how we want to do stuff. As Larry said, the other 20, 30 minutes of video, right now we're temporarily storing them in a different location, which is accessible, but very likely nobody will come back and look at that video, right? Because it is not well organized and not very well indexed and accessible. So we are relying right now just on the few pictures we can capture, to put together those reports.
Thank you both. Mark, do you have a question, or I've got one too? What do you think is best?
So sorry, my mic was muted. So yeah, I do have one question that has been asked also by the audience. You've mentioned inspection of an SRU stack and process piping inspection as well. Could you just go quickly over a list of parts of the plants you inspect, maybe starting with the top 3 use cases? Larry?
Vessels, I would say, if I'm going before Mauricio, anything that's a little wider than 20 inches, lower explosive limit, so explosibility, the presence of explosive atmosphere is mitigated. Whether there's oxygen or nitrogen doesn't really matter to us as of now. Clean or dirty doesn't really matter. We try, depending on what the equipment contents is, to not touch the walls or the floor or the roof. If we can do that, if we accidentally touch, we can clean it up very easily. So vessels, as far as equipment types, vessels, stacks, columns, reactors, flue gas sections, interconnected pipes between pieces of equipment. The challenge is using that very first flight to do your assessment of the interior space, and you're just kind of scouting out to see where your obstructions are, what you might run into, what the current condition is. And then the second flight really is the flight where you do the data capture. That's how we've been trained by flyability, and that works very well for us as well. So yeah, it's really, if you have the width and the height, you can even mitigate turns and things by utilization of the range extender. So we've had to use that a couple of times. We believe it saved and gave us the ability to retrieve the vehicle and fly it back because it was a bit of a dodgy path to get to where the inspection target was. So by identifying a location downrange a little bit or downstream of the entry point and using the range extender, we were able to complete some dodgy flights with regard to loss of line of sight, etc., inside the equipment.
So maybe just
I just want to expand. Everything he said is also applicable. We don't work on offshore, in production areas, onshore, in chemical plants, in gas processing plants. So we've now experimented all these applications in almost everywhere within Chevron.
Okay, yeah, this is a lot. Maybe just to reverse the question, has there been one place where you just gave up trying?
Hmm.
We've actually done columns that were tunneled. So every X amount of feet there was a manway or a grid, and within these grids is an entry egress area for somebody can climb a ladder and go from tray to tray to tray. And we've even mitigated that by doing a segment at a time. So not being clear what was down below the next deck, let's say, you would fly the LEOs down through and over, inspect that area, and then once it was safe and once it was clear, send a person in, and they would basically hold the LEOs, and basically we'd fire it up, and they would let it go down to the next level. So we mitigated that way. That would have been a very difficult flight to do from top to bottom without personnel being involved. We were able to do it, and it still saved tons of time.
Absolutely.
I love that.
All
And
right.
I have a follow-up related question about, replacing the need for having a person enter a confined space with, by using a robot. Have you quantified anything about the hours that you have, removed the need for a person to enter a confined space because you were able to use the Helios 2 or some other robotic solution to gather visual data? Do you have any numbers on man hours not needed in confined spaces or hazardous situations?
Not really. Right now, we're in this process of adoption, so the number of vessels we're doing with robotics is still very small compared with the number of vessels we do with personnel ingress. What I mentioned before is that in those vessels where we've done robotic inspections, we have quantified that in most cases we reduce the inspection time by 50% in almost any environment. So that has been the main indicator that adopting these technologies will give us a huge advantage. So that's the goal. That's what I was mentioning during the presentation. All these tests and demonstrations, and everybody's happy, and we are too, and we understand, but that's not the end. I mean, we need to make everybody change their ways to use these technologies as a normal way of doing business. And that's the challenge. That's where we are. That's the fight. It's no longer about the pretty pictures and, look how good I can tell there is a pit there or this or the other thing. Is the very big step of going from just a few demonstrations to everybody using this technology.
So I guess the other piece, I mean, for myself, I've probably had 700 ROI questions, and I just kind of wonder, is there something that I could publish, or can we rent a blimp that just flies around all the Chevron facilities or all the oil and gas industries and just says, here's what it's worth? It's very challenging. We have identified, we know how much scaffolding costs. We know how many people it takes to put up scaffolding and then some weeks later take it down again. We know about how much time it takes to perform an inspection with an inspector. If you extrapolate some of that stuff out, you come up with some number of savings. if you can contract a turnaround schedule for a process plant that typically costs you X amount per day to be down, you can extrapolate some value there. That's one of the things I wish, between external aerial vehicles and flyability and Elios, I wish there was some of that information that came with the vehicle, that it was just canned like default costs that we could just publish. That would help that discussion.
We'll do what we can. We'll try to get you a package. What I want to just sum up real quick. What I just heard from Mauricio is that using a tool like the Elios 2 has the potential for cutting in half the time needed for an inspection. Is that right, Mauricio?
That's correct. Yeah.
And then Larry, you were saying we know at least that it has the potential to reduce turnaround times, definitely will replace the need for scaffolding, not just the materials and the labor required to build the scaffolding, but also the time required to put it up and take it down. So those are just some concrete metrics to point to. I think and those are helpful. I'm sure we have other folks on here who might be internal evangelists like you guys are for the adoption of drones and other robotics, but face that culture challenge, right? Inside any big organization or even medium-sized, there's the buy-in challenge. And I mean, Larry, you spoke to this by simply putting the drone in the hands of someone else who may have never flown a drone. That's one way you can move forward with that sort of culture shift in an organization. Having people start realizing this is just a tool. It's not an exotic solution that only one person in the universe knows how to use. It's something you could use. That's something that you could use, and it's practical. It could actually help you do a job.
Zach, quickly, I just want to comment very briefly on what you said. I don't know that I would characterize what I said as eliminate the need for scaffolding. We approach it as reduce or eliminate.
Right.
So,
right. Yeah, I'm sorry, and I'm speaking freely. I'm just talking about inspection, visual data collection, but absolutely maintenance requirements. You're never going to get away from needing scaffolding completely. So I'm rambling, but I really, we're over time now. But I was wondering, Mauricio, you touched on this, but the last question, and sorry to steal your thunder, Mark, but I feel like Mauricio was going this way, and I really just want to hear about this from him and from Larry. Where do we go next? Where do you go next? But also, where do we go next for adoption in general? How do we push things forward? What do you guys think?
Yeah, the silver lining on this economic situation right now is giving us a lot more exposure to a lot more people internally. I am getting a lot more phone calls and emails about the utilization of these systems that I ever had in the company. So the challenge is, to demonstrate that these solutions are capable of offering the same answers and that will have a reduction in cost and time and and risk. And we will do that by repeating and trying and attempting and pushing these solutions in our facilities. The future of using remotely operated systems and robotics in our facilities is very clear to us. As Larry mentioned, it makes absolutely no sense to have people roaming around in a facility that runs explosive materials and toxic materials and high temperatures and elevated structures. So the future of using robotics and remote systems for inspection is very clear to us, and it has been for many years. So we are going in that direction, and we're going to continue working with you and with other companies, to hopefully get there sooner than later.
Thank you so much. And Larry, do you have anything to add?
No, not really. I think I said way too much already.
If you have one more minute, just I know there's been a question from the audience. I think there's people listening today that are in the same situation as you, so they're asset operators, and they're wondering, how they should get started with incorporating drones in their operations. But there's also inspection service companies that are interested to hear, what should we do to work with a major company like yours, to should we look at drones, or is this a prerequisite to work with somebody like you today, like Chevron, I would say? So it's a double questions. Is what would be your advice to those people wondering if they should start their own drone program, and is it a requirement today, if you want to stay in the game as an inspection company, to use UAVs in your services?
For my part, if I was standing up a robotics inspection company and considering the return on the investment, this is my opinion only, I would be focused on internal inspection, because there's an immediate savings of dollars for the customer with regard to time, schedule, and then if you couple in the ability of the system itself to get the imagery that you need to make business decisions, there's a significant amount more money, in my opinion, that can be saved for inspection with an internal drone versus an external drone. That does not mean that external drones are not important. We have 6 of them, and they do a very good job for us, and we use them for a variety of reasons, and they have lots of different payload options, which makes them useful. But the challenges with airspace, with the challenges with potentially regulatory compliance, with the challenges with licensing a pilot with your FAA in North America or Civil Aviation Authority, wherever you may be in the world, all of that goes away, for lack of a better term, and you can get straight to the business of collecting data, because the flight time for these vehicles is approximately 12 to 8 minutes. So if you think about it in those terms, and you think about what you can do in that seemingly short period of time, it's incredible. Once you get the vehicle started and you're inside inspecting, those 10 minutes seem like 30 minutes. It really does. You can get a lot done in a very short period of time. But the challenges with regard to regulatory environment and what you're able to do, how much money you can make, how much money you can save, seems like it'd be very, very attractive to start with internal inspection. Second part of the question, working for a company like Chevron or any Exxon, Motiva, Shell, Total, PDVSA, etc., have your ducks in a row, have processes, understand the permitting conditions in the regulatory environment where the facility is located, be available, turn over good quality data, be prepared when you show up, start with one job and then the 2, then the 5, then the 10. The next thing you know, you're an expert. And, oil and gas companies talk around the water cooler at conferences. Sharing resources happens all the time. So what typically happens, it's no different in any other form of life. The cream rises to the top. And I think that's one way to get very busy, is be very good at what you're at and be available.
Yeah, I just want to add, and maybe underline what Larry said about the economics. You need to start this conversation by knowing our business. If you don't know how much we spend in the scaffold, ask. If you don't know how much time it takes to do one operation, go ask, right? The first time you talk to somebody about using these tools, you need to be prepared to tell them, this is how much money, this is how much time you're going to save. So, I mean, if you are trying to replace a few $100s for somebody to go inside a vessel with a few $1,000s that will take to have one of these machines on site, it's not going to work unless you present the whole vision of every single aspect of the process that have nothing to do with inspection, but that account for the total cost of this work.
All right. Yeah, that was very interesting. Maybe, and your quick advice for asset operators, should you insource, outsource, do a mix of both? when it comes to using drones for
To,
asset
to me,
management?
the word is minimum value product, right? You need to find the applications where you can get the most value out of these solutions with the lowest cost for the company. You need to prove that you can save money and time. And once you do it one time, they will call you for the second time. If you select the hardest one, where the margins are the smallest, where the pictures may not be the best, where it's going to take a lot longer, you're going to be in trouble. So you need to plan and sit down and look very carefully to each one of the applications and select the ones where you can claim victory very quickly.
Yeah, for my part, I think this kind of goes with the previous question about what do I need to do to work at Chevron. And one of the things I would say about should you do in-house or should you do a hybrid approach, or the bottom line is the technology is available and you should be looking at how you can use it. You're not going to be blazing a trail. If you're just now considering using this, you're probably in last place. No problem. Use it. Whether you use it through a trusted contractor, whether you go the route to purchase your own vehicles and train people, what I would say is use the technology. If you have technology and somebody has approached you about a particular problem, don't oversell. You need to constantly have a risk-based approach in mind so you don't oversell. If somebody says, can you fly inside this thing, and they pull out a drawing, if it looks a little tight, it probably is. If it's got a lot of obstructions in it, it's probably not a good candidate. But there's many, many other uses for the technology. So I would say don't oversell and use the technology. You can use it whether you buy it yourself or you have a contractor come in.
All right. Thank you very much.
Guys, we're obviously way over time, so I think we're going to wrap it up. But I just want to thank you both so very much on behalf of Flyability and on behalf of everyone who tuned in today. We're really grateful to both of you, Mauricio and Larry, for sharing your time, your expertise. And thanks as well to everyone who joined us. We really appreciate you guys being here today. So that's all. We'll be in touch soon via email with a recording of the webinar. Thanks so much, and be safe out there, everyone.
Thank you.
Bye,
Hey,
everyone.
everybody.
Thank you.